Okay guys, so what you're looking to do is looking to get the equation of a tangent to any given line, okay? So an example will be, I'm going to mix up question 5 and I'm going to do question 8. Reason being, one of them's in the form h minus x minus h, the other one's in the form x squared plus y squared plus 2gx plus 2fy plus c, etc. Right? Now, what you can do is this, you have a circle, you know the centre of this circle is 4 minus 3. Using the x minus h squared plus y minus k squared equals r squared formula. All I did was match up the minus 4 to the minus h equals 4, and the minus k to the plus 3, k equals minus 3. Right? Upon completion of that, what we then know is there's one of these on the outside, a 7 minus 4, and I have to find the equation of a tangent. You happy enough with that? Now, to find the equation of a tangent, what you have is, you can do it like this, and you have a line here like that, and what you can do is, you get the slope of this one to this one. So we're going to get a y2 minus y1 over x2 minus x1. Let's call that x2 y2, x1 y1. Put it in, and what we're going to get is minus 4 plus 3 all over 7 minus 4, which is minus a third. Turn minus a third upside down, 3. So perpendicular slope is 3. Then all you have to do to get the equation of the tangent is it's a line, and then you put it in and you get y minus y1. Now it has to be this point here. Can anybody tell me why does that now have to be x1 y1?
That's the line.
That's the point that's actually on the line, while this one isn't. So you can't use that one anymore. Okay. So now we got to be y minus y1 is y plus 4 equals 3 into x minus 7. Then you have y plus 4 equals 3x minus 21. And then, 3x over, so minus 3x plus y plus 25 equals 0. Okay? Can anybody else give me another answer that's exactly the same?
3x minus y minus 25.
3x minus y minus 25 equals 0. Now, that way makes sense. That way is already using existing information. Are we happy with that? Yeah. Now, there is in your notes, there is a way of getting the equation of tangent just by plugging numbers straight in. Okay? It can be worth having. You do need to know how to do it that way, so it'd be fair you just keep doing it that way. But just to explain what the equation actually does, okay? The equation actually does is this. So what the equation actually does, just remember that there. So what we have is you have equation of a tangent, and it looks like this: x minus h, x1 minus h, plus y minus k to y1 minus k equals r squared. Here's what you do. H value is 4, k value is minus 3, the x1, y1 value, so you're substituting in this one, this one, this one, this one, this one, this one, this one. Everything but the generic x and y is going to be a number that's substituted in. So all we do here is you put in x minus 4, bracket, now x1 is 7, and y1 is minus 4. So we're going to have 7 minus 4. Then we're going to have y minus k, which is y plus 3, bracket, y1 plus y1 minus k, which is going to be minus 4 plus 3 equals r squared, which is 10. 3 times x minus 4? 3x minus 12, yeah? Because that's a 3. 7 minus 4 is 3. That's a minus 1, which makes that minus y minus 3. Bring it over to minus 10. Look what happens. 3x minus y minus 25 equals 0. Same answer. both times. Okay? There is no shortcut around this. You do need to know the first way. Okay, but I'm saying that's what that formula does. And there's a g squared version of that formula that does the same thing. Okay? But I think it's just as easy to do the slope and the equation of the line, really, isn't it?
Yeah.
It's not too much difference. Okay? Just showing you what it means anyway.
So why would you use the bottom of the curve?
If it's in this form here, and instead of getting h and k, you're going to get g and f. Okay?
Yeah.
So, an example would be, Kim was saying, why would you use the bottom one? Well, you can look straight away at this one and you can say that's 2gx plus 2fy. And you use the c value as well. So you can straight away say that c is minus 15, g is minus 1, f is 2. Okay? And you can put it straight into that formula there without much thought. Now, the way I'll stick to doing these, and the way I've always stuck to doing these is I write down the centre of the circle, which is minus g minus f, right?
Yeah.
Which is the centre of the circle, therefore it's going to be 1 minus 2. The point on the outside is minus 5 minus 4. So I'm just going to do what I always do. I'm going to get the slope. What? Oh, 3, 2. I'm going to get the slope, okay? So the slope, therefore, is going to be, we'll call this one x1, y1. This one x2, y2. Slope is going to be minus 2, all over 1 minus 3, which just gets me 2. Perpendicular slope is going to be minus a half. Equation of a line. I actually really don't think there's much in the difference speed-wise. One of them actually makes sense though. Yeah, I like this one as well. So y minus 2 into, sorry? Minus a half into x minus 3. 2y minus 4 equals minus x plus 3. X plus 2y minus 7 equals 0. Right. Bread and butter, right?
Yeah.
Very easy enough. Now, move on to something a bit different. Now, these ones here. Alright. Verify in each case that this is a tangent of a circle. There's a long way and a short way of doing this. Right? The long way of doing this is going x equals 10 minus 2y. We've already done this, haven't we? In an exercise already. You get x, use this the linear equation, this the quadratic equation of the circle. You get one letter on its own in the linear, and you plug it into the quadratic, and then you multiply it out. What's 8x? So 8 times 10 minus 2y minus 16y plus 60 equals 0. Everybody happy with that?
Yes,
you multiply it out, you get a quadratic. You should only get one answer for the quadratic. You should get one y value and one x value, and that technically proves it's a tangent. Right? Nothing we haven't done before. Second way of doing it. Okay? Second way of doing it is to first find out the radius of the circle. Radius of the circle equals g squared plus f squared minus c. C is 60. 2gx is 8x. G is 4. And f is minus 8. Put that into this formula here. And we're going to get 4 squared plus minus 8 squared minus 60. And we're going to get the square root of 6420, is it? Yeah, root 20, also known as 2 root 5. Okay, and what's going to happen here, guys, is that, do you remember the centre of the circle? Okay, the centre of the circle is minus g minus f, yeah, which is minus 4 and 8. Do we have a formula that can tell us the distance of the line to a point?
Yeah.
D equals ax1 plus y1 plus c all over
X squared and a squared plus b squared.
And if this distance
Equals 2 root 5.
equals 2 root 5. It hits once. If it's less than 2 root 5,
It's in the circle.
and it hits
Twice.
if it's bigger than 2 root 5,
It doesn't hit at all.
doesn't hit at all. So many ways to skin a cat, so to speak, right? So what we have here is A is going to be A equals 1, B equals,
-2.
C equals
10.
10. Then we're going to get 1 times x1, this is x1, y1 for this one. 1 times -4, minus 2 times 8 plus 10, all over the square root of 1 squared plus 2 squared, and what that's going to get me is -4, -16, -20. Is it -10 over root 5? Huh? Just give me a second with this. Yeah. It's going to be the modulus minus 10 over root 5. 10 over root 5 is in fact 2 root 5. So, same answer for both of them. Okay, happy enough with that?
And that's what you're saying, therefore.
Therefore, the distance of the line away from the centre is the same as the radius. Therefore, it has to be a tangent because it only hits once. Okay, so the closest distance to the line is the perpendicular distance away from that centre point, and that's equal to the radius. Okay, lads, one more off the road. These are the generics. Find the distance from the point outside the circle to the point of tangency. So in all of these questions here, what we're going to have is we're going to have a circle, and in this circle we're going to have a random point on the outside. So a point like this one out here, and you have your centre of your circle. And remember, what's the deal with tangents? They only hit once, like so. So what we're going to do is we're going to draw an equation from the centre of the circle to the point of tangency. This will make a 90-degree triangle, and therefore obeys Pythagoras' theorem. I'll show you. So what we get is if I draw this one to this one here, and this one out to this point here, right angle triangle. Now, in all these questions, I'm going to do question 20. Oh wait, this one, 20 is a good one because it has all the numbers are included. So this is the point 2,5 is out here. I'm going to learn everything I can about this triangle. 2gx equals -2x, g equals -1. That means that's going to, remember the centre circle is -g minus f. So that's going to be 1. And then 2fy equals 4y. F equals 2. That makes that -2. The c value is -20. The radius, therefore, this length here, to operate a Pythagoras theorem, I need to first find out the red distance, which is the radius, and then I'm going to follow that red distance by the green distance, and then I can find out the blue distance. The blue distance is the difference between this point out here and the point where the tangent actually occurs. So what we're going to do is we're going to do r equals square root of g squared plus f squared minus sig. Put that in, and we're going to get -1 squared plus 2 squared minus 20, which is plus 20, square root of 25, radius equals 5. That's one down. Next one, I'm just going to use a bargain basement distance formula.
Yeah, that's very good.
Okay, x1, y1, x2, y2, distance formula equals 1 minus 2 squared plus
-2
minus 5 squared. We're expecting a bigger distance than 5. It's the hypotenuse. It has to be bigger than 5. I'm going for root 50 or 5 root 2. Okay, so it's going to be 1 squared plus 7 squared is root 50. I'll just leave it as root 50.
5/2.
Otherwise known as 5/2. Okay? Next thing after that, Pythagoras' theorem to find out the length, or I will call it m, from here to here. So once we get that, just going to be root 50 squared. We put it. There's no advantage putting 5/2 down really, but it's root 50 squared equals 5 squared plus m squared. 50 equals 5 squared plus m squared. M squared equals 25. M equals 5. What type of triangle is this? Isosceles, and that angle therefore equals that angle. If you needed to, if there was some carry on question, that's additional information you get from that.